Good day, everyone. I'm making this video of the solution to a Physics 20 problem that somebody has asked me about. And it turns out that depending on where the student is at in Physics 20, there might be a couple of different approaches that you can take. The question says you have an object that's accelerating from rest, and the rate of acceleration is 2.5 meters per second squared, and it accelerates at that rate of acceleration for 5 seconds. At the end of the 5 seconds, it's reached its, we can call it its final velocity or final speed or maximum speed, whatever you want to call it. And whatever that speed is, it continues moving at that speed for a full minute. The question is, we need to find the total distance traveled by the object in the entire journey, and we also need to find the average speed of the object. So I'm going to cut to the chase here and talk about how you would determine average speed. Students at this point in the course should already be familiar with this formula, which is on your formula sheet, that says the average velocity of an object is delta d over delta t. And put into words, what that means is an average velocity. And this is true whether an object is accelerating or moving at a constant speed or doing some combination of those things, like the object in our question is. This will always work. What it's saying is the average velocity is the change in position divided by the change in time. And when you're dealing with objects that maybe are traveling in one direction and then a short time later are traveling in a different direction, we need to consider the vector nature of the d and the vector nature of the v. So that's why we say average velocity is change in position over time. However, in this case, we can assume the object is traveling in a straight line the whole time, so we can dispense with any vectors and directions. What this formula becomes is average speed, so the v without the vector symbol means speed instead of velocity, is equal to, and I've always just said, rather than deal with the deltas, average speed is total distance divided by total time. So when we look at this question, this I think is why you're asked in this question to find the total distance and also the average speed. And the reason is you can't find the average speed until you find the total distance. There's one other thing that we're going to need to know here, and students at this point in time should be familiar with the concept of acceleration. And on your formula sheet, there is a formula for average acceleration, which I have always, on some level, I've disliked this formula. I understand why it's given on the formula sheet in high school physics, but at the same time, most of the situations that high school students deal with accelerated motion is uniform acceleration. So we don't often talk about an average acceleration, we just talk about an acceleration. And how I have always chosen to treat this formula is to say acceleration is final velocity minus initial velocity divided by time. And I can take that one step further. If directions are not important, then I just say acceleration, the magnitude of the acceleration, is equal to the final speed minus the initial speed divided by the time. And it's these two formulas, along with something else, that we're going to need to use to answer this question. So we'll come back to those two formulas in just a second. But in the meantime, let's put as much information on this graph as we can. We know that it accelerates at 2.5 meters per second squared for 5 seconds, which means that this portion of the graph where the speed increases from 0 meters per second to some value happens over a time interval of 5 seconds. We also know that the other portion of the graph where you have an object, where you have the object moving at a constant speed, that portion of the graph happens over a 1 minute interval, which means from the 5 second mark to the end of this graph is 60 seconds, which means the end of the graph is 65 seconds after the beginning. The other thing we need to know in order to answer this question is you need to know that speed that it's reaching at the end of the 5 seconds. And this is where we're going to use this formula at the bottom of the screen. Because the acceleration has a magnitude of 2.5 meters per second squared, the initial speed is 0 meters per second, and the time is 5 seconds. We can put those into this formula and get 2.5 meters per second. That's a mistake on my part. That should say meters per second squared. I'm not sure if I said meters per second squared and just didn't write it, but it doesn't matter. The acceleration is 2.5 meters per second squared. This is equal to VF, which will be the speed that it reaches at the end of the 5 seconds, minus nothing over the 5 seconds. So you end up with VF over 5 seconds equals 2.5 meters per second squared. If you multiply both sides of that equation by 5 seconds, you're going to get VF equals 2.5 meters per second squared multiplied by 5 seconds. One of the seconds cancels with one of the seconds in the meters per second squared, leaving you with, I guess that's going to be 12.5 meters per second. So now we can put that on our graph. This has a value of 12.5. Now, how are you going to use all of this information? We're finally ready to go. How are you going to use all of this information to find the total distance traveled? Well, students at this point in the course should also know that with a velocity time graph, you can find the displacement by looking at the total area. I'll just put that down so we can see what I've just said visually. If you have a velocity time graph, whatever the graph looks like, the area is equal to the displacement, the change in position. I don't use the delta here. You can use the delta if you like. On the other hand, if you have a speed time graph, so we're talking here about speed and not velocity, then the area is equal to the distance. I just felt the need to mention that if it is a velocity graph, the area is giving you displacement. If it is a speed graph, the area is giving you distance. So what we need to do is find this total area that I'm going to roughly shade in. We need to find the following area. And when we say area in this context, literally what we mean is the geometric area. So I'm looking here at a triangle and a rectangle. This triangle here will have an area of 1/2 the base times the height. This rectangle will have an area of length times the width. So what do we get for the area of the triangle? We get 1/2 the base. Well, the base is 5, and it's seconds. I don't know how picky you need to be about the units here, but it is a base of 5 seconds. And the height is 12.5, and it also has units of meters per second. It's interesting that when you multiply seconds by meters per second, you're going to get meters, which is what we're after. Anyway, we can take 1/2 times 5 times 12.5. So that's 0.5, which is the half, times 5 times 12.5, which means that area of that triangle is 31 point, I think I saw 25 meters. I'll just double check. Yep. Now, if we take a look at the area for the rectangle, I'm just going to wiggle it over a bit here. The area will be equal to the length of that rectangle, which if I take a look at this rectangle, it goes from 5 seconds to 65 seconds, which is 60 seconds for a length. times the width or the height, whatever you'd like to call it, which is 12.5 meters per second. So what do we get? Well, we multiply 60 seconds by 12.5 meters per second. And we get 750 meters. And what that means is that the total distance, which is one of the things you're asked for in this question, is equal to whatever 31.25 meters plus 750 meters is, and that's going to give us 781.25 meters. So that's the first part of the question. We've answered the part of the question that says, what is the total distance? Now to find the average speed is simply going to be found by taking the total distance of 781.25 meters divided by the total time of 65 seconds. While I'm here, I better just add these numbers together. I'm pretty sure I got it, but it's been a long day. Divided by 65 gives me about 12 meters per second for the average speed. By the way, I don't know why you would do it in this question, but average does not mean add things together and divide by the number of things you're averaging, not in the context of motion. You have to find an average speed by taking total distance over total time. So that's how you would do this question. There's at least one more way you could do it by using kinematics formulas, but looking at the nature of the question, I would say that at this point in time, the student is only familiar with graphical approaches. So anyway, the total distance is 781.25 meters, and the average speed works out to be about 12 meters per second. I hope that helps. Have a great night.